So as you take a look at this table, there's one value that I do want you to have memorized, if there's anything out of this, and that is sine of 30 degrees. If we know that sine of 30 degrees is 1/2, you can fill in a whole bunch more of this table. So based on that one piece of information here, everything else is going to follow from that I do here for like the next 2 minutes. What always goes with 1/2? Yep, square root of 3 over 2. So if the sine of 30 is 1/2, then I know the cosine of it must be root 3 over 2. The same thing goes at all of the 30, 60 intervals. So like if I know that sine of 30 is 1/2, then I know its partner has to be sine of 60. So sine of 60 then is root 3 over 2. And if that one is root 3 over 2, then its partner, of course, must be 1/2. So I'm able to fill in all that stuff just from that. Next up, I want to jump from 60 over to 120. Now hopefully you can kind of visualize to know whether that means that it's going to be the root 3 over 2 or the 1/2. But if not, this is how I'm knowing. I'm picturing the circle, and I'm going from 60 over to 120. Notice they have the same height. I'm not changing my height there, it's the same height. So that means the values are the same. The sine is root 3 over 2. And of course, if that is root 3 over 2, I know its partner is 1/2. So you notice across the verticals and horizontals, it basically reflects. Now I can just keep following this exact same pattern where like I know that is root 3 over 2, so its partner has to be 1/2. And if that one's 1/2, then I know it's root 3 over 2, and so on. So from just following our pattern, I know all of those. Now there is one thing I haven't taken into account yet though, right? Positives and negatives. We gotta look for the positives and negatives and see what they all are. And again, I can know that because of my unit circle picture. I know that in the unit circle, sine, which is my y value, remember sine is y, is going to be negative in quadrants 3 and 4. So that means everything after 180 makes sine negative. Okay? A cosine is negative whenever we're going to the left, because cosine, of course, is our x-coordinate. So that's quadrants 2 and 3. So I go to quadrants 2 and 3, that's between 90 and 270, and I can make all of my cosines in there negative. And we'll be able to do the exact same thing to fill in any other positive and negatives for some of the rest of those we come across here. And so I was able to use all of that information just to be able to figure out the 30-degree intervals. Now, one thing I haven't touched, though, is the 45-degree. This is another one that's worth memorizing. Both numbers at 45 degrees are the same for sine and cosine. What are they?
Square root of 2 over 2.
Yep, root 2 over 2. And so both of them are root 2 over 2. And if I know that, then I know that all of the 45-degree increments, so there, I'm skipping the horizontals and verticals, so I can fill in now all of these root 2 over 2's, and then it's just a matter of filling in positives and negatives. And so I filled in all my root 2 over 2's, and again, the signs are going to work the same way, where everything that's to the left, cosine is negative, and everything that's down, sine is negative. All right, we've filled in just by following a couple patterns there. We only knew a couple things. I knew the sine of 30 was 1/2, and I knew the sine or the cosine, doesn't matter which, of 45 degrees was root 2 over 2. The last things we need to fill out when it comes to sine and cosine is the horizontals and verticals. So like 0 degrees. This is where just remembering which one's x and which one's y is really what you need to know for it. So like 0 degrees, that's over here. At 0 degrees, I'm not going up at all. So sine is 0. But I am going over to the right, and it's a unit circle, so we're going over the full radius, which is 1. 90 degrees, I'm going straight up. So my sine will have a value, but cosine will just be 0. So we're going up 1 over none. At 180, we're going over but not up. So sine is 0. Cosine, we are going over 1, but since we're going to the left, remember cosine must be negative still. And we can just keep following those same patterns to get all the rest of those. 360, remember, that's the exact same point as 0. So your numbers at 360 should be the same as they were back at 0. And so we're able to follow all of those patterns just to figure out what sine and cosine were. And remember, what did I actually memorize there? I memorized sine of 30. I memorized sine of 45. And I knew that sine is y and cosine is x. Basically, everything else came from that. So it's not a ton of raw memorization. It's just knowing a few facts and then applying them. Now again, looking at how we apply things is going to help us, for instance, with tangent, which comes next. In order to find our tangent values, what is our definition of tangent, or how do I calculate it in these terms? Yeah, tangent is sine divided by cosine. So if I want to figure out what tangent of theta is, I'm going to do sine of theta divided by cosine of theta. All right. So let's take a look at one of those in particular then. Let's go over to tangent of 30. Well, in that case, I would have to be doing 1/2 divided by root 3 over 2. Now, some of you hate doing this type of problem, so you're going to memorize this value. And if that's the route you want to go, that's fine. I don't like memorizing it. I tend to calculate it out. But go with whichever way works for you. If we do calculate it out, just as a quick refresher what that work would look like, that would be 1/2 times 2 over root 3, which gives me 2 over 2 root 3, which simplifies to 1 over root 3. But remember, I do need to get that radical out of the bottom, so we rationalize the denominator. That is, multiply top and bottom by the square root of 3. So that whole thing actually equals the square root of 3 over 3. So that's my tangent value there, is root 3 over 3. Knowing that, you can actually know a whole bunch more values again. Like everywhere where we're going to be doing 1/2 divided by root 3 over 2. For instance, over here at 150. You shouldn't have to recalculate it. You basically know what the result is. All right, so every place where sine is 1/2 and cosine is root 3 over 2, I know that tangent is going to be root 3 over 3. But once again, we then have to go back and look at the positives or negatives. The first one was positive divided by positive. That's why we got a positive number here. Our next one is positive divided by negative. That gives me a negative. After that, it's negative divided by negative. That's positive. And then finally, negative divided by positive is negative. And that's how we can know if our tangents are positive or negative. We're just following that same kind of a thing. All right. Next up, the only other one that really takes much work to figure out here is the root 3 over 2 divided by 1/2. In order to find that, you basically do the same kind of work as we did down here, although this one ends up being just a tad bit easier because there's no rationalizing of the denominator. When you do this particular one, it just gives you the square root of 3. Now again, some of you will choose to memorize that, that's fine. Or you can do the work. But once I know it that one time, every time sine is root 3 over 2, I know the tangent is going to be root 3. And so I go through and I can fill all those in, and then it's just again a matter of where is it positive and where is it negative. If my sine and cosine values are different signs, I get a negative. When the signs are the same, I end up with a positive. Now, I said that those were about the only ones that were really tricky here. Because, like at 45 degrees here, I'm doing root 2 over 2 divided by root 2 over 2. What's anything divided by itself? 1. There you go. Nice and easy, right? You didn't have to do a ton of work. I mean, you can, but you don't need to. So every time they're both root 2 over 2, I know they're 1s. And again, I then go back and just fill in my signs. If the signs are different, I end up with a negative. When the signs are the same, like negative divided by negative, it gives me a positive. So there's just a few little gaps here, right? My horizontals and verticals. Well, there, it's just 1s and 0s. We can divide those in our heads quick and easy. Like, what is 0 divided by 1? Yes, we can do that one. That one's 0. 1 divided by 0, that's the one we can't do. We cannot divide by 0. And so then we can know all those values for those reasons. So those are the patterns and how we can be filling all this in. Now we have left one big gap in our picture here, right? We haven't yet touched our radian values. Well, the first radian value should be really easy. What is 0 degrees in radians? 0, yeah. From there, though, we're faced with another situation kind of like our first tangent value. You have a choice of either memorizing what 30 degrees is in radians, which is actually what I've done because it come up so often, I just ended up remembering it. But if you don't, you can always go back to our formula. Remember, d over 360 equals r over 2 pi. And then you just plug in what we have here. In this case, I know that it's 30 degrees, so I plug that in for d, and I can do that work. And yes, you can do this one without a calculator, because 30 times 2, well, that's 60. And 360 divided by 60, yes, you can figure that out without a calculator as well. It's 6. And so that'll help you with all the reducing. But you just go through that work if you don't memorize it. But like I said, I did memorize it. It's pi over 6. And once I know that that is pi over 6, I know that every time I'm going up by a 30-degree interval, so like here's 30 degrees, every time I go up by a 30-degree amount, I'm going up by pi over 6. So in order to fill in all those values, all I have to do is add pi over 6. All right, now let's take a look at how that counting works. Like if I'm going up by pi over 6s, that means I start with just 1 pi over 6 here. And every 30 degrees, I'm adding 1 to that. So my 1 pi over 6 becomes 2 pi over 6, then 3 pi over 6, then 4 pi over 6, and every 30 degrees, I'm putting in another pi over 6. And of course, I would continue doing it. I just didn't want to keep writing it. So, why did I write them above the actual spot where I'm supposed to write them, though? Because some of them can be reduced, right? So I'm going to ask you to do the reducing when I put it in there. So like 2 pi over 6. 2 over 6 reduces to a third. So that's going to be pi over 3. 3 pi over 6. That's pi over 2. 4 pi over 6. 2 pi over 3. 5 pi over 6 doesn't actually reduce. So that just stays 5 pi over 6. And 6 pi over 6 equals what? Pi. Now, that's a good indicator because I want you to know, just because you've seen it so many times, that 180 degrees is pi. Now, you'll also know that for other reasons as well. Like 360 degrees is what in radians? 2 pi. And so if it's 2 pi for the full circle, then half the circle, 180 degrees, must be pi then, right? The nice part about knowing that is that when we reduced my 6 pi over 6 here and got pi, it checked out. I was able to verify that from another angle, and I know I didn't like skip a step or something like that. And so that's going to help you to keep all that stuff straight. And we just keep reducing through as we go along, and that got us most of our radian values just by doing that. But it didn't get us all of them. I got a couple gaps here. 45 degrees. What is 45 degrees in radians?
Pi over 4.
It is pi over 4. Now again, that one's come up so often I've ended up memorizing it. But if you don't want to memorize it, that's fine. You don't need to. What's your alternative? Plug it in the formula and do the work. Or there's actually ways you can visually figure it out, but we'll talk maybe more about those tomorrow. So that means every 45 degrees we're adding a pi over 4. So then 90 is 2 pi over 4. And of course that will reduce to pi over 2. 135 is 3 pi over 4. 180 is 4 pi over 4. And of course that reduces down to pi. So again, another verification that we're on the right track there, right? And then another 45 degrees would be 5 pi over 4s. And so on. When your table is complete, this is what you should be looking at for all of your values. Make sure that everything is correct in your table now. So we're now going to be continuing our theme of no calculator work today, and actually for the entire week, with a problem like this now. So again, keep those calculators away. All right, so there's actually two ways about doing this very first problem. First up, the long way that we'll tend to have to use on all the others as well. First, we decide if we're going to use sine, cosine, or tangent for this particular problem. We're going from the angle that we're given, so that's from the 45-degree angle. I have the 15, which is the opposite side, and I'm trying to find A. That is the adjacent side. Opposite and adjacent tells me to use tangent. So, just like we normally would with our calculators, I start by writing down tan 45 degrees equals opposite over adjacent. It's just that when we did this with calculators before, I'd generally do the cross multiplication, get A equals before I did anything else, but because I know what tangent of 45 degrees is, hopefully off the top of my head, if not, at least in the table, I can just find out what that value is as a nice pretty number and plug it in. Tangent of 45 degrees is 1. So 1 equals 15 over A. I still got to figure out what A is. So personally, I think of it as multiplying both sides by A. If you want to instead write it as 1 over 1 and cross multiply, that of course will still work. Either way you do it though, you're going to end up with A equals 15. Now I said there were two different ways that you could get this. That is the long way, and it's the way that works every time basically. But the other way is that you might have actually just observed what type of triangle it is. Because if it's a 45-degree angle here and a right triangle, it's a 45, 45, 90 triangle, and all 45, 45, 90 triangles are, of course, isosceles. Which means that this leg must be the same length as this leg, and so you might have just been able to look at it and know, oh, it's got to be the same, so it's got to be 15. And that would also work there. But that only works conveniently enough for this one, really. Some of them not quite as conveniently, like this one. So repeat the process here, write down our problem, and again, start setting it up and even solve it through. And this one should feel a lot like the last one because once again we're going from this angle and we know the opposite, we want to know the adjacent, so we're going to be using tangent. It's just that in this case, the tangent of 60 isn't going to be something quite as simple as 1. We need to know the tangent of 60 degrees, so we go back to our notes. We go back to the table that we made. And so notice, if you don't have that table, if you can't fill in the values that way, you're not going to be able to do it. So tangent of 60, square root of 3. So square root of 3 equals 24 over A, and then we solve from there. And again, I can either multiply both sides by A or root 3 over 1 and cross multiply. Either way you do it, you end up with A root 3 equals 24. And so to get A by itself, we're going to divide by root 3. So we end up with 24 over root 3. Now, that process is fairly straightforward. It's just that this particular one ends up being about as tricky one as you might see, just because we still have to go ahead and rationalize the denominator. So I'm going to multiply top and bottom by that square root of 3. So that gives me 24 root 3 over 3, but of course that can further simplify. 24 over 3 is 8. So A equals 8 root 3. That's as good as it gets. All right, so when you work this one through, you should get an answer here of 5/2, or 2.5, or 2.5. I'm not picky about which way you formatted it. All right, so this one, when it's totally reduced and all that, you should be getting an answer here of 9 root 3. So in this problem, as we set it up, we can see this one involves the opposite and the hypotenuse, therefore we're going to use sine. So we do sine equals 10 over 20, which reduces down to 1/2 just to make it a little bit easier to see there. So basically this one is then asking the sine of what equals 1/2. And if you don't know it off the top of your head, you can always go and check in your table, although this is one that I hope you do know off the top of your head, because it's the one I want you to memorize. A equals 30 degrees. All right, so all of these up to this point have been in the triangles where we set it up ourselves and then we go from there. They're not all that way though. What if you're just given a trigonometric equation to solve? We're going to work through those as well. So write down this problem and then we'll work it through here together. And of course, one variation you'll notice here is that sine is of pi over 6. Because we have to be able to do this same process whether I give you the degree angle or the radian angle. But the same process is going to be the same. So like in this case, sine of pi over 6. We can find that value right away. What is sine of pi over 6? Sine of pi over 6 is 1/2. Because pi over 6 is the same as 30 degrees. And so we set it up as 1/2 equals 21 over x. And then we're just solving that. Much easier to look at now, right? And again, notice, this is easy because we had that value in our table. If we don't have our table set up and we can't look at that, this is going to be a tough problem to do. All right, last step, we cross multiply to solve from there. You should end up with x equals 42. All right, so when you end up working this one through, you should just get 36 root 3 as your final answer there. Now in this case, we start by figuring out what the cosine of 4 pi over 3 is. It's a negative 1/2. Now, we're still going to cross multiply, but if the negative is giving you trouble, think about how to do that cross multiplication. Remember, negative 1/2 is just the same as a negative 1 over 2. And if you do that, if you were confused, you just do that and then it's no longer confusing, I would hope. And so when we cross multiply, then we end up with a negative x equals 18. We then go ahead and divide both sides by negative 1 to figure out that x equals a negative 18. And we're done. All right, so a nice way to make your life a little bit easier here, go ahead and simplify the fraction. Notice this whole thing just equals negative 1/2. So we're looking to see where cosine equals negative 1/2. And so as you take a look at your table, you would end up getting theta equals, the most common answer I hear is 120 degrees. But you'll notice that's not the only answer you could give here. Like even in your table, where else do you see cosine equal negative 1/2?
240.
Yeah, also at 240 degrees, right? Although we could even go a little bit crazy with this because that's just going around the circle the once. You actually could go around the circle as many times as you need to in order to be able to get to other angles as well. So like you could even go with like 480 degrees and it would still give you negative 1/2 and a whole bunch of stuff like that. But even just working within your table, there's actually two other answers that you might have given here. How about 2 pi over 3? Or 4 pi over 3? How do we know whether to give our answer here in degrees or radians? Well, I didn't tell you, so you actually wouldn't know in this particular case. How are you going to know in the future? Well, first of all, when you see this type of problem on assignments or tests or anything like that, it should be specifying for you whether it's in degrees or radians at that time. But in terms of like in general, outside of like the math kind of format, up until this point in your mathematics career, everything has been in degrees. So everything has been assumed to be in degrees up until now. I can tell you though that after this class, every time you see a problem like this, the assumption is going to be, unless you're told otherwise, that you're actually in radians. Radians are the default, basically in any place you're going to be seeing these types of problems come up after this class. So just realize that once you're out of here, like in pre-calculus, calculus, stuff like that, you're always going to be assumed to be in radians.